Hey everybody, I'm Elliot Williams, managing editor of Hackaday, and our first speaker today, Nadya is meta, mathematical, and musical. She's into how machines can augment human abilities, but also into the machines that build the stuff. She's in residence right now at Nervous System and starting a lab at University of Washington called Machine Agency, or Machine Agency. It's a double entendre. Today, she's going to talk to us about math and music and the dirty details of design, production, scaling, and distribution of the music and objects that her band, Construction, used with their latest EP. So please welcome to the Hackaday Superconference stage, Nadya Peek.
Thanks for the introduction, Elliot, and thanks to Hackaday and Supply Frame for putting on this conference, which is always very fun, especially Sophie and Brian and Mike. It's actually not totally true what he said about the intro. I was going to do a talk about projects that I had planned to finish by now, but because they're not finished by now, I'm going to just give you the wrong talk where I give way too many slides, and it's like many projects, most of which aren't finished. And if you're watching this like later, maybe watch some of the other talks first, because this one is probably not going to be that coherent. But last year when I was here, I gave a talk about the cardboard machine kit workshop that I was supposed to teach in Shenzhen that went terribly, terribly wrong. And so when we showed up and they were like, build machines, and there was nothing there, we had to kind of scramble all around Shenzhen, which is a good place for this problem to happen. And so David Craner and Calvin Zhang and a bunch of other people and I all came together to build the circuit boards that we needed to teach the workshop, circuit boards that were already supposed to be there in an afternoon. And it was like at the time, something that I thought was very stressful. It was also like 5 days after my PhD defense, and it was in China, and I don't know, it was very stressful. But then I came and gave a talk here about it, which was very validating, because everyone was like, yeah, that does sound hard. And then I was here for Monday and Tuesday after the SuperCon, and Tuesday, you might recall, last year, Trump was elected. And so I was suddenly like, okay, well, I was like previously really upset about things like not having my circuit boards for workshops. And now I have like a whole new perspective about what trouble is. I'm kind of not really thinking that the same problems are problems before. I have been invited to the Obama administration White House a bunch of times as like a maker. And there, I felt people were listening about what's the future of manufacturing and digital fabrication, and how are we going to be inclusive and diverse, and how are all of these technologies going to be moving forward? And then all of a sudden I'm like, wait, what? Now we have to worry about our friends being deported, and like, you can just be like a shitlord and be president? I don't know. It was really disconcerting for me. And so I went back, and even though I had this big plan of I finish my PhD and I do these weird machines, and everything is going to be great, all of a sudden I'm like, oh, maybe not everything is so great. And I had lunch with a friend of mine, Carrie Lynn, who is a really old, he's going to be mad if I say that, but he does a lot of infrastructural work. So he worked on Apple Talk back in the day, he worked on 802.11, he does a lot of field bus work for smart buildings and the Internet of Things now. And he always gives me these quotes from American authors, like another flaw in the human character is that everyone wants to build and no one wants to do maintenance, which I thought really spoke to his labor, because he's spending all this time working on the infrastructure that makes the internet work, and no one really knows who he is. And then he said, Nadya, why don't you read this essay by Hunter S. Thompson, which he says, when the going gets weird, the weird go pro. And so what is the point of the projects that you're doing, and maybe if that's the stamp that you want to leave behind, just focus on that and don't worry too much about how everything is playing out. Just like keep doing, don't get paralysis. And so I spent a lot of time doing all these projects, and I give talks about basically the same projects quite often, machines that I've built, and the control systems that you can use to construct those machines and how it's like better if they're networked and if the machines themselves are also networked. And that seemed like it was something that I was articulating something and people were listening. And then I also was visited earlier this year by the guy from Mythbusters. I never watched Mythbusters. I'm not a real nerd, I guess. They visited my desk, and I did all these demos, and they put it up on the internet, and they don't link to any of the source code. I'm like, it's all open source. This is not. What's the point of disseminating this if no one is going to build it? And so I was a little disenchanted by that because I'm like, oh, I'm just like a cool hacker girl that's good for entertainment. I mean, if that's all it is, then why not just have it be fiction? You know, what are we working on? And so to be able to better cope with all of my existential anxiety, I started playing a lot more music with my band, which is only 2 people. This is my bandmate Marco Attasari. And the nice thing about music is that you can really not be too cognitively engaged with the process that you're doing. You're just playing. And I think that both I and my bandmate Marco Attasari do in our day jobs have a lot of things going on that are much more planning. Why you're planning on this, and you have lead times, and everything has to come together. And if you're playing music, it's just like there. This is what's happening now, and everything else is sort of less important. And it's kind of fun. Marco is more famous than me. He's formerly the head of design of Nokia. And the best PR we ever got from our band was when The Verge ran this story about how Microsoft totally killed off Nokia. And it said, that Nokia is now gone. Its chief designer is playing bass in some band. And then there's a picture of our band. And so, you know, there's some overlap there maybe with at least how you can do the promotion of the projects. But it also got me thinking about, you know, what are the feedback loops that you have when you're doing this kind of production? So with music, you press a note and you can hear it, and if it's off key, like you can hear it immediately. And then with software, you know, if you want to write something, you can write it and then you can test it, and you can make unit tests, and it's like relatively quick to be able to get feedback. And if you write firmware, like okay, you have to write the firmware, and then you have to cross-compile it, and then you have to put it on your target. But then also it's like still not that slow. But then once you start getting to, I have to design the hardware, I have to order the parts, I have to populate boards, like things are going to go wrong in manufacturing. You get these bigger and bigger feedback loops. And so then your time to success is like, you have to be really stubborn. Luckily, I am really stubborn. But why that method of engaging with technology, I think, is it's problematic because you can't necessarily, the ideas that you have spontaneously, you can't incorporate into the work that you're doing. And in music, you know, there's all kinds of futzing that you can do afterwards. So in music, there's access at any level. After you've played the first, if you record it, then you can distort it, you can record over it, you can do all these different things. And so how can we make a parallel of that in technology? And it's not just the production process, but also, you know, where are you engaging in an ecosystem, or like if you have a supply chain or a country that you're participating in. If we really are closing down borders, lots of things change in a system like that. We're like, okay, all of a sudden I can't get chips in China that are from Taiwan, or you know, some physical things can really change your hardware designs in ways that are unexpected. And so in a time where like everyone just wants to be a platform and your projects are just mined as the gold of the graph of the platform, it's like nice to also think, okay, I want to be able to improvise with technology and do kind of silly things and silly projects with a community of people that I care about, like the Hackaday community. Or this was my neighbor, Nico Fine. And this is a very simple hacker. I think this is a very classic hacker. He was like, you know, wouldn't it be cool if while I was playing guitar, if I dipped, there'd be a flamethrower? And so to solve that problem, he just has a can of Axe and a lighter and like a servo and an accelerometer. It's like, yeah, this is like a straightforward, I wanted this thing, and so I did it. Or Jeff Sturgis, who runs a makerspace in Detroit, was like, okay, well, when I'm trying to jam with my friends, I can't necessarily always play in key, or I don't remember what all the keys are, so why don't I just put LEDs in my keyboard so that as keys change, I at least know which notes are like A-okay and which notes are going to be kind of funky, etc. This is like a, this straightforward, this is all stuff that you would see in, featured on Hackaday. This is Jonathan Ward, who I used to work on a lot of machines with, who now builds these tiny houses so that you can bring, and then you start working at this community scale where you're like, okay, well, I want to be here now. Or Sid Mead's talk yesterday where he's like, where do you live and where do you go? This is both in one. You can just move places where you're going. And so being like a micro platform, I think, is something that I am starting to be more interested in. This is you can recognize this and think that it is a DVD, but it is in fact not a DVD. It is a record that is being produced with this amplifier in which he is encoding audio that is being played live into the room into a circular disc for playback on a vinyl record player. And it just so happens to be that a very convenient place to get flat plastic things is as writable DVDs. And so can we be distributor of music? Jeff Warren, who runs Spectrogram Records, this record label, and I also started in response to precarious times this sort of joke company called VLux, stands for Vapid Luxury. We sell really expensive textiles, so like a $300 or $400 blanket or like a $100 apron. And we don't say what it's for. We're just like, okay, buy this product. And then we secretly give all of the money to the Mexican American Law Defense Education Fund or Planned Parenthood. So if you can, people just want really fancy things, so you might as well take advantage of that. I also like these, going back to my own knowledge of like machine building. I went on a brief like mini vacation to Oslo, where there are two cool hacker maker spaces called Bitref and Fellesverkstedet. And they're working on their own version of open source machines that are easily made with materials that they have there. So this is an high density fiberboard machine with like Delrin chamfer rails for moving around. And it's not just, this is not just like you could make this machine based on this, based on the design files that are online, but it's also this community of people that are all hanging out and refining a design together. And so maybe it's not only about what the source code that you have developed together, but it's also about maintaining and incorporating new people into a community that engages in these kinds of projects. So this is we were like working on this machine that we wanted to have an interchangeable printer milling head, a 3D printer milling head, and then we were like, oh, we're hanging out in this hackerspace, and it turns out there's like a company there that runs open source Beagle Bone Cape for motor control. So we stole it because he wasn't there. He gave us permission 12 hours later, but by then we had already reflashed all the firmware. And so then you have like not only this one project, but this proliferation of projects that are all around this community of people who are interested in similar things. So you have open source, open hardware, 3D printer boards made by people who are also making them as installations for local conferences. This is Jakob Nielsen, who brought a plotter that was running on similar software that they had all been developing together at Bitref, and used it as like a backdrop for a party. And so it's not just a hack. It's like this is a local community that is bringing in income by demoing weird stuff like machines. And there is, to some extent, something that has always bothered me a little bit about, who gets to do projects, like people that are too busy or don't have access to the right education or tools to be able to do this kinds of projects. Are we really privileged to be allowed to be doing all these like weird hacker projects? And And I think the answer is yes, but you can share your privilege by engaging other people. This is Torbjorn, and in this hacker space, he showed up as like a teenager who had ADHD and didn't really know what to do with his time, and then he really went full on machine building, and then he started building machines for local companies as a livelihood, and then also teaching in the local technical school. So yeah, maybe there is a way in which this can become viable. This, of course, is Norway, which is sort of a magical place where everything ends up working out. And for me, you know, how do I manage to do all these weird projects? I am in academia where you can just write grant proposals to do weird things. But then, for me also, that feedback loop is really strange and distorted. Like I'll write a paper about a project that I've done years after it's already been online for a long time, and other people have made it and other people have contributed to the project. I got into a big fight with ACM about the open access policy that they have for their papers. I'll talk about that maybe afterwards if anyone wants to be angry at academic publishing. So last year, we didn't have any of the parts. So this is all just like stream of consciousness ranting about what might be wrong with the world. But last year, the one problem I had was I didn't have the materials to teach this workshop for cardboard machines. And I recently, with James Coleman in Cambridge, taught a similar workshop. And so if things had gone the way we planned, you know, we would have had all of these parts, quite loud, all of these parts ready already to be able to do not just machine building, but also once you have an idea of what exactly it is that you want to make. So in this particular workshop, we were working with a lot of architects who want to make strange shapes. If you have some idea of what you want to make, can that inform the machine that you build for that application, so that you're going first from what is the design that you're trying to produce, and then you create the manufacturing infrastructure, and that can all be in service of the design that you're working with. So this is a Hackaday conference, which stands for Association of Computer-Aided Design for Architecture, which is sort of strange now, I guess, because what kind of architecture doesn't use computer-aided design? But anyway, and so the first day-ish, they just built the same cardboard machines. But then in this community and how do people end up working together on projects thing, we wanted to be able to simulate what are all the different parties that are involved in a project like this, and how can we kind of shine a light on the pain points of communication that go through a field project like this. So if you have a designer and a contractor and maybe like lots of subcontractors that all have to make parts that fit together, and some of them use inches and some of them don't, and you have shipping and logistics, and they decide that like half of your packages that you ship later should arrive sooner, and then your assembly goes terribly wrong, and the field directors don't have drawings of what exactly it is that you need to be assembling. These are all, I think, problems that everyone solves every project over and over again, and there isn't necessarily a lot of innovation happening in that space. Like, how do we work better together as community on these kinds of projects? And so we tried to simulate it by dividing our workshop group into a design group, a manufacturing group, and an assembly group, and limiting the amount that they could communicate with each other so that it would sort of simulate these problems that you might have in production. And they also had to make the machines that would make the design that they had. And it was a relatively simple design. It's like this site-specific installation that was going to fit onto a column in the space. And to be able to make the site-specific installation, they needed to have triangles, and all the triangles were different. And so they decided to make a machine that measures 2 angles and 1 length so that you have a fully defined triangle. And then once the machine is in position, they put these poplar dowels, square dowels in place, and then nail gun them, and then label each triangle so that then they can do the site-specific installation. It's all like zip tied together and eventually installed in this space. They made a short video about it. So this is also my band. we'll segue to in a second.
I checked the math so
now I can't talk over
many
myself.
times. I ran the numbers over and over again. I couldn't seem to verify. I'm not taking any blame.
Happened at the same time. But you can see, like, in one of the things that also happened, this is not Autodesk, so I can complain about Autodesk. The workshop happened in Autodesk's build space, and they have a lot of random infrastructural building problems, so their water cut out on the second day of the workshop. So we only had, 3 times 8 hours to do this full thing. And then in the middle day, they were like, you can't come into the building because the water mains are broken. And they also don't have regulators on their compressed air on each drop. And so there was like a robot arm trying to 3D print at the same time as we were using a nail gun. And every time the robot would extrude, our pressure would go down. And then if the robot would stop extruding, suddenly our nails would shoot further. It was very problematic. And so we did like one of the days of the workshop, we just moved to a random site and squatted in like in an atrium in an MIT building because we couldn't go back. So anyway, there were lots of problems with that workshop. But you can see that still they managed to successfully communicate with each other to do this assembly of a site-specific installation, but not the disassembly, so they're Autodesk. And and I think that there's interesting insights there, but then what are we going to do next with that? It's, I think, an interesting question that I have percolating for what am I going to work on to make those things better. I don't think that maybe the answer is just making more and more machines, even though that is very fun. So we were, I am in residence at this computational design studio called Nervous System, and that sounds really fancy. Basically, Nervous System are friends of mine, and they were like, why don't you just sit here and work on projects instead of sitting at home and working on projects. And it's very fun to hang out there because we get to do weird stuff when we feel like it. So, can you electroplate your 3D prints reliably, especially if you have these weird forms? Does electroplating work better if you add all kinds of convection in your baths, or if you want to, this is like a attachment that we made to the otherwise not very reliable Dremel 3D printer so that we could print silicone, or like from a caulking gun, to be able to make weird flexible forms. And Nervous, Jesse and Jessica and I were thinking about, can we do something with music, or can we do something with the music that we're producing, and maybe do something with video. And they have this project that you guys know their puzzles by any chance? Have you seen them? And so they have a method of creating puzzle pieces, which is, it's like a simulation of crystallization happening in a super cooled liquid. And so you have like crystals forming, and there's a boundary. They simulate that boundary, and then they use that as like the cutting edge for their puzzles. And that's something that works in 2D, but also works in 3D. The way that they have different puzzle pieces is they like because math are able to say that there aren't only 2 phases of material, liquid and solid, but there are n phases of material, so every puzzle piece is a different phase in this simulation. And so they were thinking maybe with construction, the band, and the Laplacian growth project that we've been doing for a while, we can do some kind of crazy, like, you guys playing and then weird choral forms growing out of you, and it looking cool also. And so I'm just going to show you, because we haven't actually finished this project yet, I'm just going to show you some tests that they've been working on for it. First, we did this 3D data capture. We didn't have a green screen, so you can see that we have all kinds of problems with the pixels that get picked up. So in the 3D capture, we also will have like these bulbous extrusions that are, so green screens are good is the moral of that story. And this is kind of the tests that we started doing. And so the way that you can get more out of your simulation is just by playing it backwards or by playing the same thing from multiple sides. And I personally really like symmetry in imagery. Jesse and Jessica think it's cheating, but come on, it's really cool. Or things that are built in and kind of conjoined. This one isn't set to music yet. Or surface from, here you see that there are some things going wrong with the meshing. Then, okay, so these forms are working pretty well. How do you incorporate it with like the 3D data that we captured from, how do you incorporate it from the 3D data that we captured from the Connect? Well, that all looks super 1997 still, but bear with me. And I guess we're really used to slick visuals and compositing from movie industry, but it actually is compositing is relatively non-trivial. This is also problematic because this is only me. Where's my bandmate? This was not my choice. They did that. And then can you also use the music to do weird patterning on the surface? So this is picking up on the frequency or the beats per minute and using that to project a pattern onto the surface. And here's another symmetry. Here's another symmetry test. So this project, which is unfinished, and I would have talked about it more in detail if it was finished, partially is bringing back like you're making music and you also are wanting to do projects with that. And there's this ritual that goes along with listening to recorded music, like playing a CD or going back to spectrogram records. How can you, in this time, have that same kind of ritual? I think that it's one of the reasons that vinyl is popular again, because you do have this, you have a physical artifact and you have a ritual of playing that involves you engaging with a player, which is hardware. So does it necessarily have to be a vinyl? Could it also be a sculpture that is a strange form that is also the music player? So these are projects that we're exploring sort of in between the band and the machine stuff. And so I guess this sort of meandering early morning talk mostly is just questions that I have, like how can you make technology more improvisational and have the feedback loops that you allow yourself to engage with while building things be more immediate? How do you do that not only in your own projects, but in communities and where you're working on a shared goal? And if you're building that technology, is it for you? And if it's not for you, how do you make sure that you're including people? And so, yeah, sorry about the title. The Laplace transform probably can't help. Thanks.